Alright, 711, or 7111. Mrs. Frank loves the clock in her classroom because it has school colors, green and purple. The shape of the clock is a regular dodecagon. So remember, a regular dodecagon is 12 sides. So this has 12 sides. Uh, with a radius of 14 centimeters. Okay, so has a radius of 14 centimeters. Centered in the clock's face is a green circle with a radius of 9, so this radius here has a radius of 9. If the region outside the circle is purple, which color has more area? Alright, so this is kind of a complicated problem because in order to do this, we need to find the area of the dodecagon. And I'm just gonna dodecagon. We'll just call it do. Minus the area of the circle is going to be the area of purple, right? And the area of green is going to be the area of the circle. Okay, so this is the area of the circle. So we need to find a couple things. We need to get the area of the dodecagon, and then we need to get the area of the circle. So let's do the dodecagon. So they told us this has a radius of 14, so from here to here is 14. And I can figure out this angle in here because I know that if I take 12 times n equals 360 and then I divide by 12 on both sides, 360 divided by 12 is 30. That tells me that each of these angles here are 30, and then half would be 15. So that's 15, and then we know if that angle's 15, then we know this angle right here is 75. So I know this is the height. Oopsie, I don't know what I did there. So I know this is the height, and this is my x. And so to get the area of this, I need area equals 1/2 base times height. So I need the base and the height, and I'm going to get that from here. So to get x, that's going to be cosine 75 equals x over 14. So I'm going to multiply cosine 14, oh excuse me, not cosine 14, cosine 75 times 14 equals, so this is going to be 3.623 equals x. And then we know the height is going to be equal to sine of 75 equals the height over 14. So then the height of the triangle is going to be 14 times sine 75, which ends up being 13.523. And then I'm going to put them in my formula here. A equals 1/2 the base. Now remember, x is 3.623, and I'm going to multiply that by 2. So we want that whole length of the base. So that's 7.246 times the height, which was 13.523, and the area equals 1/2. Actually, I don't need to do that. So let's just use our calculators. 0.5 times 7.246 times 13.523 equals, alright, so I get 48.994, and that's the area of the dodecagon. And the area of the circle, okay, is going to be, we know we have a circle with a radius of 9, and that's going to equal area equals pi r squared. So the radius is 9, so that's going to be 81 pi. And so now to get the area of the purple, we take the area of the dodecagon. Oh, what did I'm not quite finished here. I found the area of one triangle, not the area of the dodecagon, and I just realized that. So the area of the dodecagon of 12 sides is going to be 12 times 48.994. Okay, so then the area of the dodecagon is going to be 12 times 48.994 equals, and I get 587.928. And so this is 587.928 minus 81 pi. And we can let our calculator figure out what the area of the purple area is. So minus 81 times pi is, and I got 333.46 centimeters, and that's the area of the purple. That's the shaded region. The area of the circle we know is going to be 81 pi, and 81 times pi is equal to 254.47, and that's centimeters squared. Now, as we can see, it says which is bigger, the purple or the green. Well, clearly the purple area is much bigger.